Let's solve these problems in this lecture. Last lecture we studied about the mirror formula and we looked at a few cases also. We solved a few problems for point object. Okay. Here what we have are extended objects. Okay. So in the first problem we have to find the length of image. Length of image, height of image. Okay. Meaning the same thing. Height also is a length. Okay. By the way. So you don't really have to be confused. Okay, so I have this object of 3 centimeter. It is kept at distance here 30. Focal length this. Okay, here the object is kept differently. in this case here the object is kept like this. Okay, directly above the principal axis. Now here some part of the object is above principal axis and some part below principal axis. In the third case the object is along principal axis. It is along principal axis. Okay, and here I have this type of a wire frame. Okay, this is my object. Okay, it is a wire frame. Let me write it here. It's a wire frame. Wire frame. Okay, so this length is 20 centimeter and these two are 5 and 5. 5 and 5. There will be some image. Okay. So what will be total length of that image? That we have to find out. Okay. Now, the next question is related with these type of problems. So this is a rod of 5 centimeter length. What will happen if I have a very small rod of length DL, very small, okay, a small, thin short rod of length DL. It is kept along principal axis. It is kept like this, in this orientation. Distance L from a concave mirror of focal length, some focal length. What is length of image? Okay, we have to find out. And then these two general problems, okay, numerical problems. At what distance from a concave mirror of focal length 30 centimeter an object should be kept. So I have one concave mirror, focal length is given 30 centimeter. The question is, I have one object. Now where should I keep the object? I want to get a real image. I want to get a real image of half size. A real image of half size. Where should I keep the object? I want to get a virtual image of double size. Where should I keep the image? Okay? You understand this? And then I have a square plate. All these are linear objects. Objects like this, rod. What will happen if I keep a plate, a square plate in front of a mirror? I am going to get a plate-like image, a square plate-like image. What will be its area? Okay, that is the last problem here. Okay, so let's start solving it. The same mirror formula we have to apply. Okay, let's see. I am going to give you one example how to solve it. In the first case, we are starting with the first case. Note down these problems, all of these problems. Note down all of them. Try to solve if you can, of course, and of course you can. Okay, there is no doubt about it. Try to solve it. Get some answer. Whatever comes to your mind, apply that. Get some answer. And now we are going to solve it. The first case here. Okay, first thing. The moment you see a problem in optics, geometrical optics, lenses, mirrors and all, the first step should be to decide the sign convention. Decide the sign convention. Okay, what is going to be the sign convention? Okay, what will be sign convention? This is my mirror. Okay, the object is like here. This is my pole. The object is kept at a distance of 30 centimeters. So let's say that this is my object here. The height of object is 3 centimeter. 3 centimeter. This distance is 30. Light rays. The light rays which will be eventually responsible for the image, they will go towards right, they will be reflected, they will come back towards left, and depending on whether they meet or they do not meet, I am going to have a virtual or a real image. Okay. Light rays are going towards right. They are going to make image. Okay, so the distances to the right of pole, okay, distances to the right of pole becomes positive. To the left, it becomes negative. Okay, now above the principal axis is positive. Above is positive and below is negative. Okay, you see, this is not always the case. This is not always the case. We will see. We will do problems where you see this is always positive. Above the principal axis, always positive. Below, negative. Left and right, this is not always positive. It will depend on how my mirror is kept and how my object is kept. Okay, we will see problem where it can be like different. Okay, we will do it differently. Now, focal length, the magnitude. You see, when it says focal length, then it means the magnitude, which is 20 centimeter. What will be 1 over V? Is 1 over F minus 1 over U. Okay, it is going to be 1 over minus 20. Okay, the last lecture we discussed how it is going to be minus. So here in this lecture, we are not going to do the same things again and again. We are directly going to solve the problem. Okay, developing method of how doing it. Now minus 1 over minus 30. Minus 30. Now when you do that, you are going to get this answer, minus 1 over 60. Okay, so this V is equal to minus 60 centimeter. I am going to get an image somewhere here. This is my object. I am going to get an image here. This is my object here. I am going to get an image here. At a distance of 60 centimeter from the mirror, means from the pole. Okay, but only that is not sufficient. I have to find height also. Whether it will be above the principal axis or it will be below the principal axis, that also we have to find. That we find using magnification. Using magnification. Okay, what is magnification? Magnification is equal to height of image over height of object, and it is equal to minus of V over U. Okay, understand this? Okay, so this will be equal to height of image over height of object is going to be minus of what is V? V is minus 60. Okay, V is minus 60 over U is minus 20. Not 20 but minus 30. Minus 30. What do I get? I get minus 2. Minus 2. Magnification is minus 2. Okay, try to understand this. Magnification is minus 2. Height of image will be n times height of object from this relation. Okay. Now this will be equal to minus 2 height of object. What is height of object? It is 3 centimeter. It is above principal axis. I will write plus 3. Plus 3. So height of image is minus 6 centimeter. Minus 6 centimeter. That means the image, the length of image will be 6 centimeter. The height of image will be 6 centimeter. And it will be below the principal axis. It will be like this. This will be 6 centimeter. This is how the image will form. Now, what will be nature of this image? Is it real or virtual? The image is formed on the same side of the object. This is a case of mirror. Image is formed because of reflection. Reflected light are going to meet only on the left. Image is also on the left. That means this image has been formed after actual meeting of reflected rays. That means it is a real image. It is a real image. Okay. Is it inverted or erect? Object is above the principal axis. Image is below principal axis. It is inverted. Is it magnified or diminished? Is it magnified or diminished? The height of object is 3, height of image is 6. Its size has increased. it is magnified. Okay. And by the way, okay, try to understand this very, very clearly. Very, very clearly. What is the meaning of minus sign here? If height of object is positive, height of image will become negative. That means if object is above the principal axis, image is going to be below it. If height is negative, height of object is negative, height of image will become positive. All of that is happening because of this minus sign here. Minus sign tells us whether the image is going to be erect or inverted. That is going to be erect or inverted. So in this magnification has two components. Magnification can be positive and negative. Okay? Magnification can be positive or negative. If the magnification is positive, that means I am going to get an erect image. Erect image, what is the meaning of erect image? If object is above principal axis, image also above principal axis. That is the meaning of erect image. If object is below principal axis, image also will be below principal axis. That is the meaning of erect image. For that case, this M will be positive. If M is negative, it is going to be negative, it is going to be inverted. Okay. Now we have two components of magnification. Okay. Magnification is going to have sign, it is going to have some sign and magnitude. It is going to have some sign and magnitude. Because of this sign, the image is becoming erect or inverted. Okay. So if sign is positive, okay, and sign is negative, if it is positive, that means I am going to get an erect image. Erect image. Negative, I am going to get an inverted image. Inverted image. Okay. Now, the height of image, the size of image will depend on this value here. That is the magnitude. The magnitude. If it is 2, if it is 3, if it is 4, 5, 6, if it is more than 1, if this thing is more than 1, the height of image is going to be more than height of object. That means I am going to get a magnified image. And if this magnitude is less than 1, let's say that it is half, it is 0.5, then the size of image is going to be smaller than the size of object. Then I get diminished image, magnified and diminished. Diminished. Okay, do you understand this thing? Very, very clearly as you can do. Okay, now, one other very important thing, very, very important. Magnification is minus times V by U. Magnification is minus times V by U. If it is negative, it is inverted. If magnification is negative, inverted. If magnification is positive, it is erect. Okay. Now, try to understand this. Magnification is positive, let's say magnification is negative. Let's say that magnification is negative. That means these two must be of same sign. These two must be of same sign. If this is negative, this also is negative. If this is negative, this is negative, and this is negative. If both are negative, that means the object and the image both are on the same side. What type of image it will be? Real or virtual? It is going to be a real image. So for a real image, this is a case of reflection. This is a case of reflection. That means the image is formed on the same side as the object. Object and image both are on the same side of the mirror. That means these two are going to have same sign. If these two are going to have same sign, then image will be real. And then magnification will be negative. That means it will be inverted. So a real image is always inverted. And then you can extend your logic. An erect image is always virtual. Always virtual. And this is very, very important. You have to remember this. For real objects, okay? Okay? For real objects. If my object is real, and I am getting an erect image, that means it must be virtual. If in all the cases, the objects are real objects. If my object is real and I am getting an inverted image, that means it must be real image. You stand in front of a plain mirror, what type of image you get, real or virtual? It is a virtual image, and virtual image is erect. It always happens. It happens in case of plane mirror. It happens in case of spherical mirrors. It also happens in the case of lenses. If my object is real, then an erect image, a virtual image is always erect. A real image is always inverted. Now, if my object becomes virtual, then the things interchange. Then they interchange. Okay? What is the meaning of virtual object? We will see. Next class we are going to see the meaning of virtual object. Okay? That's how we find it. Okay? Now once you have this concept, you can try all the problems. Okay? Now here, the second one. Okay? Now this thing is going to be very important. Very, very important. Now the second problem. Can you guess the answer? Can you guess the answer? Object at 30, image was at 60. Now I have the same mirror. Mirror is same. What will happen if I keep my object at 60? Image is going to be at 30. Image is going to be at 30. Okay, let's see. Let's try to figure out. Now this is my image. This is my object has changed. Okay, my object has changed. Now some part of the object is above principal axis and some part below it. Okay, try to get your answer yourself. Okay, try to get your answer yourself. Let's see if you can get the correct answer. Now some part is above, 1 centimeter is above, and this 2 centimeter is below it. Okay, this whole distance is 60 centimeter. Okay, what is 1 over v? 1 over f minus 1 over u. Minus 20 minus 60. When you solve it, you are going to get this answer. I know the answer because I have solved it. Okay. When you solve it, you should be getting the same answer. Okay. This V is equal to minus 30 centimeter. Image will form here. Image will form here. They simply interchange. Object and image can be interchanged. I am getting an image here, but what type of image? Will it be real? Will it be virtual? Oh, of course, it is going to be real. I am getting it on the same side. It must be real. So it must be inverted. How long? How short? Okay, we find it using magnification. What is magnification? It's minus of v over u. Minus of minus 30 over minus 60. It becomes minus half. Magnification is minus half. Magnification is minus half. Only this is sufficient to tell me everything about image. Understand this. Minus sign. Minus sign. Magnification is negative. What does it tell me? It tells me that it is an inverted image. And thus it will be real. It is inverted, so it is going to be real. My image is going to be real. This minus sign tells me. What this tells me half? It tells me that image is going to be diminished. Image is going to be half the size of object. The object size. What is the object size? Total size is 10 centimeter. It is going to be inverted. Height of image. Height of image is magnification times height of object. Okay. Now this is minus half times. Now what will be height of object? So the image is going to be inverted and it is going to be half size. Total height is 3 centimeter. So can I say that it is going to be half of that? 1.5? Can we say that it is going to be 1.5? Okay? Let's see. This part of the image, which is above the principal axis, it is going to be below the principal axis. What it is? This is 1. This will become 0.5 centimeter. The part of object which is below the principal axis, it is going to be above the principal axis because it is inverted. Okay, it will become half of that. It will become 1 centimeter. 1 centimeter. What is total? 1.5 centimeter. I can directly write it. Okay, it is. If I look at only the magnitude, okay, it is going to be inverted, and this is a minus 3. Minus 3. It becomes plus 1.5 centimeter. The object is okay, downward, image will be upward. You can do it in 2 parts also, but it makes no difference. You are going to get the same answer. And see, one other thing about reciprocity. In this case, object 30, image 60. Magnification, double. What was the magnification? Double. What do you expect magnification here? It will become half. Okay? Reciprocity, reversal. Object at 60, image at 30. Here the image was double of object. Here it will be half of the object. Okay? Try to think about that. Alright. Now the third one. What about third one? Understand this. Very important. This is okay, very, very important. Try to understand this. When I say M is equal to height of image over height of object is equal to minus of V by U. This is longitudinal. This is a transverse magnification. Transverse magnification. That means object perpendicular to principal axis. Okay. This magnification, when the object is along the principal axis, it will be known as longitudinal. And luckily, fortunately, we do not have any formula for that. Okay, so you are saved from remembering one more formula. So there is no formula for that. Then how do I find it? How do I find it? This object has many points. I have this 5 centimeter rod, thin rod. It is kept along the principal axis. Okay, so what I can do is I can find image of all the points, and then the length between these two end points. Okay, so this point is going to have some image somewhere. This is going to have some image somewhere. Okay, then all of the image will be between those two extremes. Okay, so in such cases, remember there is no formula. First of all, okay, so it becomes simple. Okay, you don't have to remember any formula for this. This is known as longitudinal, along the length, along the principal axis. Okay, let's do this. This is a convex mirror. Okay, a convex mirror. This is my principal axis. Okay, what is focal length? The magnitude is 10 centimeter. Okay, so let's say that this is my focus. It is centered here. This is my object. Okay, at a distance of 10 centimeter. This is my object here. This is my object. So what we do is we find the image of both ends, both extremes. Let's say that the one end is here O1 and the other end is here O2. What will be distances of these ends from the mirror? 10 centimeter here, and this is going to be 15 centimeter. Okay, 10 and 5, 15. Okay, image I1, 1 over V1 is equal to 1 over F minus 1 over U. Okay, do you see? This is going to be equal to 1 over plus 10. This is the sign convention. Okay, to the right it is positive, to the left it is negative. Plus 10 minus 1 over minus 10. Okay, where the image is going to be? Image is going to be 2 over 10, so plus 1 over 5. V1 is plus 5 centimeter. So the image corresponding to this is going to be somewhere here. Okay, this is I1. And what will be this distance? This distance is going to be 5 centimeter. This is 5 centimeter. Okay. What about I2? I2, 1 over V2 is equal to 1 over F minus 1 over U2. Okay. U1 and U2. This is going to be equal to 1 over plus 10 minus 1 over minus 15. Okay, understand? This is going to be 30. So this is 3 plus 2. What do you think? 3 plus 2. Going to be positive here. So 30. 3 and 2, 5. 5 over 30. So plus 5 over 30. So V2 is plus 6 centimeter. Plus 6 centimeter. And it is expected because as we move away, the image goes towards the where? Towards the focus. Okay. So this is my I2 here. This is my I2. What are they? They are images of two extremes. 6 centimeter. This is going to be my image. So all of my image. So if you look at the image of any of these, it is going to be between these two extremes. So what is length? 6 minus 5, 1 centimeter. 1 centimeter, okay? Get the idea? Do it here, like this. Here what will you do? Okay, what type of image we are getting? Both are virtual. Both are virtual, and this you understand that in case of a convex mirror, I always get virtual image, no matter where the object is. You can note down this point. No matter where the object is, we always get a virtual image. Okay? Can we get real image from a convex mirror? Can we get a real image from convex mirror? What do you think? Okay? Can we do it? Can we get it? We can get it. Note down this point. We can get real image also from a convex mirror. From a plane mirror. Can we get real image from a plane mirror? We can get. But for virtual objects, not for real objects. What are virtual objects? We will see. I am not going to define it. If I define it, it becomes very confusing. We will understand it through a problem. Okay, next lecture. Okay, now. Now, so here we got many problems. We solved it. And what about this? The fourth one. Fourth one should be, you see, it's same. It is no different from any other. We just treat them as two objects. Okay, just two objects, O1 and O2. Okay, let's see how to find it. Let's see how to do this. 60 centimeter. This focal length is 40 centimeter. This is my first object here. I have my first object here. This object, and the second object is somewhere here. This is my second object. Okay. Let me say that this is O1, the first object. This whole thing I am taking as first object. This whole thing I am taking as second object. Let me say this is O1 and this is O2. Okay. What is distance of O1? 60 centimeter. And this distance from here to here is 80 centimeter. 60, 20, 80. Focal length is 40. What is radius? It is 80 centimeter. What does that mean? That means I have one object which is kept at center. At center. Where do I expect the image to be? Okay, we can now calculate it. But without that also I can answer. I'm going to get an image at the center. Object kept at center, image at center. U and V both are same. What is magnitude? 1. Real image inverted. Magnification -1. So I get an image of same size, inverted image of same size at same place. We can find it through calculation also. For the object O1, okay, 1 over V, 1 over V1 is going to be equal to 1 over minus 40 focal length minus 1 over minus 60. This is going to be 120. So minus 3 plus 2. Okay. V1 is going to be minus 120 centimeter. Minus 120. That means I am going to get an image here. 60 and then double of this. It is somewhere here. This will be the position of my first image. Position of the image of this object here, O1. Do you understand this? Okay. What about its size? So M1 is minus of, magnification is minus of V by U. It is minus of minus 120 over minus 60. I am getting minus 2. So height of image over height of object is minus 2. Height of image is minus 2 times plus 5 minus 10 centimeter. This is 5 centimeter. I will get an image of 10 centimeter. Magnification is negative. Negative magnification of magnitude 2. That means it will be enlarged image, magnified, enlarged, and real, and inverted. This means inverted, that's why real. Inverted, real. This magnitude is 2, it is more than 1, it is going to be magnified, enlarged. I am going to get an image like this here. This is the image. What will be its height? 10 centimeter. This is the image of first object. I am considering this to be the first object. Now what about O2? What about O2? 1 over V2 is 1 over minus 40 minus 1 over minus 80. I am expecting it to be at the same place. Let's see, let's find out. Minus 1 over 40 plus 1 over 80. 80 minus 2 plus 1. Okay, so V2 is minus 80 centimeter. I am going to get an image at the same place. Okay, what about its magnification? Magnification is going to be minus of minus 80 V over 2 minus 80 minus 1. Minus means inverted, that's why real. Okay, both are on the same side, that's why real. Inverted, that's why real. Okay. Same size, magnification is 1, same size. So I am going to get my image right here but inverted and same size. This will be I2. So this becomes my total image. So all of the rest of the points, the image will be between these two. Between these two. Okay. So this becomes my image. This becomes my image. Okay, do you understand this? So what is going to be this length? This length. This whole thing is 120. This is going to be 120. So this is 120 centimeter. This is going to be 40 centimeter. Okay, so what is the length of image? Length of image is going to be 10 plus 40 plus 5. Okay, this is also 5 centimeter. 10 plus 40 plus 5, 55 centimeters. Okay, understood? Let's move ahead. Next one is a very special problem, a general problem. Okay, a general problem, but very special one. Okay, I know how to find this. If I have this mirror, its focal length is f0. Okay, an object is kept along its short object along the principal axis. Okay, let's say that this is my object. Okay, we just solved a few problems. How to find the length of image? Okay, we just find the image of this point and this point separately. Find the distance between those two images. That is the length of image. Length of the image of this object. No big deal. But here, it's a very short rod. It's very small length. Very small length. Very small dl. This is dl. Length is dl. Now there is a very special, beautiful way of solving this problem. It's like this. It's like this. Okay. Forget about rod. Forget about rod. Think about a point. Think about a point. Let's say that I have a point here. O. Point here is O. Okay. Corresponding to this point object, I have one image here. This is my image. Okay. You understand this? What will happen if I shift this object by a small distance, very small distance? Focal length is, let's say, 40 centimeter. I am shifting it by 1 millimeter. Very small, 1 millimeter, that's it. 1 millimeter, very small distance. Image is going to change. Image is also going to shift. I can calculate the shift using mirror formula. That's not a problem. I can always do that. But if this shift is very small, for example, this focal length is 40 centimeter, I am shifting it by half millimeter, 1/10 of a millimeter. The calculation is going to be little dirty, okay, little cumbersome. Okay, of course I am going to get an answer. I will get an answer. But now there is one other easy way. It's like this. My object, okay. If I shift it by a small distance du, okay, the object is kept at a distance of u, image is formed at a distance of v. Now, if I change, if I make a small change in object distance, it is same as shifting it. It will be same as this rod. Okay, I have one object at one end here. I am shifting it to this point here by distance dl. Okay, here what I am saying is one object is kept here at distance u. I am making some small change in u, du. So there will be some corresponding change in v. This is dv. What will be dv? That's what I have to find out. Okay, and we can do it by differentiation. 1 over v is 1 over f minus 1 over u. Okay, I am making a small change in u. Let's differentiate it with respect to u. Okay, so d over du 1 over v is equal to d over du 1 over f. Okay, you understand this? Minus d over du 1 over u. I am changing u by a small distance, a small value. I want to find what is going to be changed in v, image distance. This becomes minus 1 over v square and dv over du. Okay, this thing is going to be 0. It is going to be 0. Okay, minus this thing is going to be minus of 1 over u square. Minus of 1 over u square. Okay, do you see this? So what do we get? I will get dv over du is minus of v square over u square. Okay, so what is dv? Is going to be minus of v square over u square times du. In our problem, what is du? du is equal to dl, the length of rod, dl. U is given. U is given. Focal length is given. Okay, so I can find 1 over v is going to be equal to 1 over minus f naught because this is a concave mirror. This is the magnitude. When I write apply the sign convention, it is going to be minus f naught minus 1 over minus l. Okay, so from here this will be equal to 1 over L minus 1 over F naught. 1 over V is going to be equal to F naught minus L over F naught L. Okay, so V is F naught L over F naught minus L. I put this value here, I get the answer. In place of du has to be replaced by dl. Okay, and that's it, we have the answer. Okay, length of image, you have it. Okay, we have the answer. V, keep it here, v square. U square I already know, u is equal to L minus L. Square it, becomes positive. In place of du, you write dl, you have the answer. The length. Since it is asking about the length, so I have to find the magnitude. I have to write the positive value. Okay, the magnitude. Okay, next one. A very interesting problem. Sometimes it becomes very confusing. The problem itself is not so difficult. A very simple problem. Okay, but you have to be careful while solving it. There are chances. It's a problem having potential of causing some confusion. Okay, causing some confusion. Let's see. At what distance from a concave mirror of focal length this 30 centimeter, an object should be kept to get a real image of half size. Let's see how to solve it. Real image of half size. That means what will be magnification? It's real. That means it is inverted. It is real. That means it is inverted. It will be minus. Half size. Half. Okay, that's how we do it. Magnification is minus v over u is equal to minus 1 over 2. Okay, so what is v? Is going to be equal to u over 2. Now mirror formula, 1 over v plus 1 over u is equal to 1 over f. Okay, what is 1 over v? It will be 2 over u plus 1 over u is 1 over f. 3 over u is 1 over f. Okay, what is u? 3f. 3 times of, what is focal length? 30 minus 90 centimeter. That's how we do it. Now do the next one. Virtual image of double sides. A virtual image of double sides. Double sides. What it means? What will be magnification? Virtual means erect. Virtual image is erect image. So it will be, magnification is going to be positive. Double size is 2. Okay, that's it. Minus of v over u is plus 2. V is minus 2u. Okay, so I have this thing. 1 over v plus 1 over u is 1 over f. So 1 over minus 2u plus 1 over u is 1 over f. This becomes 1 over 2u. 1 over 2u, okay, is going to be equal to 1 over f. What is u? Is going to be f over 2. So minus 15 centimeter. The object is kept before focus. I get virtual image. And this is a very general property of a concave mirror. If I have this concave mirror, this is focus, this is pole, this is focus. If I have an object, the object is kept between pole and focus. Between pole and focus, the image is going to be virtual. Okay, you can find out using this ray diagram also. This is the ray diagram. That's how it will be. This is my center somewhere. Okay, if I take okay. This is my reflected ray. If I take one light ray, okay, along this line joining the center, it is going to retrace. Because these two are reflected light. They are never going to meet. They are going to meet here when I extend it. They are going to meet on the other side. Okay. So here I get a virtual image. A virtual image. So when the object is between pole and focus, I get virtual image. Virtual image is erect. Okay. So in a concave mirror, we get all type of images: real, virtual, erect, inverted, magnified, diminished. But in a convex mirror, we always get virtual image if the object is real. Okay. I am writing this all the time. Now the last one. What do you think? What is going to be the answer? Here I have an area. It should not be difficult. It's like this. Okay, let's say that I have a convex mirror here. Convex mirror. Okay. I have an object here. Let's say forget about this area. Forget about the area. The object is kept at a distance of 45 centimeter. This is 45. 45 centimeter. Focal length is given. What is focal length? Radius is 16. Focal length will be 30. 30 centimeter. Object is here. This becomes my incident rays. Incident rays are going towards right. This becomes right. This becomes positive. This becomes negative. Okay. What will be 1 over V? Is 1 over F minus 1 over U. Focal length is going to be positive. Focus is on this side here. This is my focus. This is my center here. Focus is to the right of pole. This is pole. So it is going to be positive. So plus 30 minus 1 over minus 45. Okay. This is going to be equal to 90 here. So 3 plus 45 is 2 here. What do I get V? It is plus 18 centimeter. What is this? Plus 18 centimeter. Plus 18. Okay. What will be magnification? Minus of V over U. Minus of plus 18 over minus 45. Okay, it becomes plus 18 over 45. If I divide by 9, okay, so 2 over 5. This magnitude is less than 1. That means I am going to get a diminished image. Size of image is going to be smaller. Positive is erect. I am going to get an image like this. 18 centimeter. That means it is going to be somewhere here. If this is my object, this is my image, a virtual image. A virtual image. What will be its size? 2/5 of this. Whatever is the length. If length here is L, okay, length of object, this length of image, okay, or height of object, let's say height of object here, okay, this height of image is going to be 2/5 of height of object. Now consider this. Instead of this erect object, one dimensional line, if I have a plate, in that case every dimension, every side is going to be magnified by same amount. Okay, if the magnification is 2/5, that means 0.4 times. 0.4 times. Okay, so this becomes 0.4 times, this also becomes 0.4 times, every side becomes 0.4 times. What will happen to area? Okay, if I replace this thing with an object like this, okay, so if this is the length of object, this is length of object, okay, then area of object is going to be L naught square. Let's say it is a square plate, okay, then this also will be a plate like image, length of image, that is one side of image is going to be this. So what will be area of image? Area of image is going to be equal to Li square. This is 2 by 5 square Lo square. This is going to be equal to M square Ao square. Okay, the magnification becomes M square, the aerial magnification. Aerial magnification, okay, is equal to area of image over area of object, and this is equal to ML square. Okay, so area of image over area of object is going to be equal to this 2 by 5 square. 2 by 5 square. Okay, that's it. So area of image is going to be equal to 4 over 25 times area of object 5 centimeter square times 5. So 4 over 5 centimeter square, 0.8 centimeter square. Okay, do you see? That's how we solve it. And let's just solve one last problem for this lecture. Okay, one last problem. Okay, it is like this. Locate image. Let's see if you can solve it yourself. Okay, this is my principal axis and it is along x-axis. Along x-axis, okay, and this is my y-axis. Okay, it's my y-axis. Now, my object is here. This is my object. Okay, focal length of this is, let's say, 20 centimeter. 20 centimeter. Okay, the object is kept. The position is, let's say, 5 centimeter x coordinate and then 0.4 centimeter. 5 centimeter, 0.4 centimeter. This is a concave mirror. Where will be image? Where will be image? A confusing problem. A confusing problem. You have to solve it very, very carefully. Very carefully you have to solve. Otherwise you are going to get incorrect answer. Most of the students get it incorrect the first time they do it. Okay. What about you? Can you get it right the first time? In your very first attempt. Okay, let's see. Forget about the axis. The best thing is to forget about the axis. We will bring it. Later we are going to bring it. Forget it. Okay. Forget about it. What does this mean? Coordinate. That means this height is 0.4 centimeter and this distance from here to here is 5 centimeter. The object is kept here. The light will go towards left. This will be the incident light on the mirror. Okay, so to the left of mirror it becomes positive. You see, this is our sign convention. To the left of mirror, this is my pole. The pole is at origin. To the left of mirror, it becomes positive. Right becomes negative. What will be 1 by V? It will be 1 by F minus 1 by U. 1 by, what will be F? What will be focal length? This is pole. To the left it is positive, to the right it is negative. Focus will be somewhere here. This will be focus. So focal length will be negative, minus 20, minus 1 over. Object is on towards right. It is going to be minus 5. Okay, makes sense? This is minus 1 over 20 plus 1 over 5. 1 over 5. This is 20 minus 1 here plus 4 here. What do you think? Am I doing it all right? Okay, so what is V? It is equal to plus 20 over 3 centimeter. Okay, what we are doing? I am imagining it as one object of height 0.4 centimeter. This is not an object, this is just a point. This is a point object. It is a point object, understand it, remember it. But I am imagining. Imagine that I have an object of height 0.5 centimeter. Okay, now what will be height of image? Height of image is m times height of object. What is m? Minus of v by u times height of object. Minus of v is plus 20 over 3 divided by u is minus 5 times, this is above the axis it becomes plus 0.4. Plus 0.4. What do I get? I will get a positive answer here. Height of image is positive. Okay. What it is going to be? 5 and 4. So 1.6 over 3 centimeter. 1.6 over 3. It is more than 0.4. Okay. It is positive. That means it will be above the axis because I am going, and at what distance? Plus 20 by 3. What is the meaning of plus? What is the meaning of plus? It will be to the left. Plus is towards left. This is towards the left. Okay. So at this distance here, okay, this distance from here to here, it is going to be 20 over 3 centimeter. 20 over 3. Height is above, positive. Okay. So this is like approximately 0.5. Okay. Little more than 0.5. I am getting my image somewhere here. This is an imaginary object, so this also be an imaginary image. Okay. Try to make this difference between virtual and imaginary. Okay. Virtual and imaginary, they are different. So this will be a virtual imaginary image. Now since the object was imaginary, so we can pretty well forget about it, then forget about this also. Okay. Forget about this also. Okay. Forget both together. So that means if this is my object, this will be my image. Okay, now what will be, okay, so we located it. What about its coordinates? Now bring back the axes. Bring back the axes, x and y. This is 20 by 3. So x axis is going to be equal to minus of 20 by 3 centimeter. X coordinate. Y coordinate, this is going to be the y coordinate. Plus 1.6 over 3 centimeter. This will be the position of the image, the coordinates of the image. Okay, that's how we do it. So let's stop here. Next class we are going to do more problems.